Fala, galera. Muito bem-vindos aí. Meu nome é Leandro e eu tô aqui com o Leonardo, que foi colega de computação lá na UFC, e a gente vai fazer uma simulação. A UFC é a Universidade Federal do Ceará, né? Para quem não conhece, antes de ter a UFC das lutas, né? O UFC era só a Universidade Federal do Ceará. E a gente está fazendo um treino aí de entrevista para vaga de AI Engineer, certo? Quer falar um pouquinho sobre ti aí, Leonardo? Rapidinho, só se apresentar.
Perfeito. Então, pessoal, eu estou aqui, vou ser o entrevistado, né? E só para falar um pouco sobre o que eu faço, tá? Então, nos últimos 12 anos, né, eu venho atuando como pesquisador e professor, e agora, mais recentemente, nos últimos 6 anos, eu tenho trabalhado com desenvolvimento, né? E especificamente desenvolvimento de sistemas, né, que utilizam IA e Machine Learning.
Beleza, então a gente vai simular uma entrevista real, a gente vai fazer em inglês, né? Que as vagas são fora, as entrevistas são tudo em inglês. Então, eu vou apresentar um problema para o Leonardo, e aí eu vou dar. Bora botar assim uns 40 a 45 minutos, e aí depois eu posso dar um feedback aí. Okay, so let's switch to English now. So the problem that I'm going to propose is this one. So suppose you have a system where you have several files. Imagine like OneDrive or Dropbox or I don't know, other services like that, like Google Cloud or something. So you have a service like that, and you want to create a tool where the users will be able to do some search on the documents saved in the system, right?
Mm-hmm.
So suppose I have my documents like passport, and I want to ask like, when does my passport expire?
Ok.
Something like that, and the system will be able to answer questions like that, or when like what's my heaviest file, or what's my longest video, something like that, right? So let me write that down. So the question will be, design a system or design a tool that users will be able to search files on a file system, or where design a tool that users will be able to search in natural language, or will be able to ask questions about the files in natural language. The tool will answer these questions based on existing files. Yeah, it's a complex problem,
Okay.
but you don't have to, answer everything, and it doesn't have to be perfect. Just want to hear your
Nice.
the way you explain
I like
that.
the question. I like this problem. Okay, so as you already described what you want regarding the solution, maybe I would just ask a little bit more details. How much of throughput we will need to expect in the system? I mean, it would be used by how many requests per unit of time?
Yeah. Mm, let's think about like a few million users. People will use that like every day, and that has to be something that will work in real time.
Oh, okay, real time. So let me just put it there. Some requirements. 1 million, you said, users per day. We have to deal with that. And also you said it needs to be, we need to answer fast, right? It cannot take, so it's real time. Real time, like, to just give me an idea of how much of latency we
Well, a few seconds maybe, but it should be quick, not
okay.
much more than that.
Okay. Let me see if there is something else. These files, they are confidential. They have sensible data.
Yeah, good question. Yes, but the user will agree with the terms, and well, the company will have access to the files as well. People, yeah, let's assume everything is accessible by the user and by the company, but not by others.
Okay. Okay. So, okay. So it's how can I say that? Okay. So user and company should have access and have authorized access. Authorized access, but not others. Okay. Okay, maybe while I start thinking about it, I may ask other questions. So for sure, we will need, okay, so I start drawing some big picture of my first ideas about the system. So we have defined system. I will be thinking really high level here. So after we can start to think of the details. And I will have, of course, I will need to retrieve information about this filing system. I will also need, so I believe, so when you say we are going to ask in natural language, we will need to have an LLM here, not necessarily an LLM, but it will be, that's something more or less natural to do in this kind of situation. And what else? We need to have, we will need to index the files in the filing system by using its embeddings. So you have to generate embeddings of these files, so that when we are going to retrieve them, we can use these embeddings in order to do so. We need an embedder. Not sure. Embedder. I'm not sure if it's how it's written in English. And we will need a vector database with the embeddings and their indexes in this file system. Vector database. Vector store. So the retriever is going to retrieve from this, based on this vector store, and with the information on the vector store, he will be able to know which files are important for this specific user query he's doing. So I repeat the retriever here. At some point, we will have to say we will have some sort of API that we receive these requests. So here's a user query. User query. So it is a query through this API. And I believe we will also need to do some sort of query optimization. I don't know how to call it exactly, but we will have to maybe query parsing. I would say, I put it like this: parsing optimization, because we will need to have some control on how these the prompt we will make to retrieve this file is formed. So we will try to optimize this prompt so that we can get better results. So it will be like, it will be probably like asking some predefined questions, maybe following some chain of thought to know what characteristics of the file the user is particularly searching. So, for example, you gave an example where he needed to find a file of a given the passport, and to find the number, its number on the passport, or something like this. So yeah, we will need something like this here. So the user made this query. Just let me know if I'm if you're fine on this the way I'm proceeding, or if you have some.
Yeah, looks good. Looks good.
Looks good. Okay, so I keep like this. API query parsing optimization, and then we will send this to the retriever so that it can go into the vector store based on the embedding of the particular query, and then he will get the embedding. He will need the file too, so maybe there is some sort of request to the file system to get this particular file. Put it like this. And then
yeah, this is not important, so important, but when you say embedding, it's actually embedding.
Embedding,
yeah.
But
it's okay. Yeah.
Okay, thank you for the correction. So when we retrieve, we are going to find the most relevant documents based on the query, and then we'll probably have to re-rank it according to different rules that may be important. As I said, we are not going to look in details now, but that's just a overall vision of this. So this will be this ranking. This R here. Re-ranking strategy, and then we are going to send with the query and the most relevant documents. Maybe I'm going to put this up here. Most relevant, and here is the query. We are going to have the answer, and the answer should go back to this API here. Let me just see if there is something that I missed. Oh, of course. So we will have to. There is an arrow here from the file system to the embedder, and from the embedder to the vector store. Oh, there is also chunking. Yeah, I missed something here. Before we can embed these files, we'll have also to chunk them, because there may be big files with lots of information inside, and so we have to think how we are going to index. Maybe we're not going to index the full file. Maybe we're going to index parts of it, and of course we will have metadata to know which file a particular chunk belongs to. And yeah, I guess that would be my first impression. What's your opinion? It's more or less in the right direction, or there's something you want?
Yeah, it's in the right direction.
But yeah, I didn't consider a lot the SLO requirements, right? So as we are going to have 1 million users per day, and it's a real time, few seconds service, maybe we are going to add something here. I don't know if in your opinion there will be like very frequent queries, so that we could maybe cache them. Cache the answers.
Maybe that's a good idea. Okay, so yeah, can you explain a little more? Okay, so I understand what you're proposing here. So you get the file system. So the first part is like how to build the data set, and the second part is how to retrieve the information, right?
Yeah, that's true.
Okay. Yeah, very nice. I'd like to understand more how the query the query parsing and optimization works. Is this LLM like inside, or this is just like calling the LLM and the LLM is returning the information? How are you planning to do that? Let's say I have several documents, and I go there, including my passport, right? Maybe I didn't save this file as passport.pdf, for example, right? Or passport.png. Let's assume we have a way to process the image and extract the text from the image, right? You don't have to worry about it.
Yeah, that's an important point.
Yeah, but no worry. How how does that work? Like when the user comes and asks, like, what's my passport number? How is this information processed?
Yeah. Well, the way it is now, you have pointed an important subject that I didn't treat here. It's the case of images. So I'm more or less considering everything is text here, but that is an important point. But first, about the question you just asked. So you have a passport here. So at some point we will have this passport is going to be chunked. Of course, usually a passport is a very small file. So we're assuming it is text, so it's a small text, and it probably we were not going to break it into chunks. So we are just going to embed it, and after we embed it, it will be a vector here with some metadata. For example, we need to know which file it came from, and so that we can look at this file if we want, right? So when the retriever receives a query about passport number, this will be also embedded. The query will be embedded and it will be searched in the vector store. And then we are going to probably it will be one of the if we have a good strategy, good embeddings and a good re-ranking strategy, we are going to find this particular file, and we are going to serve it to the user. But yeah, there are some missing points here. Just based on your question, I see some missing points here. So maybe let me just suggest a few changes here, because now I see that is more, I will call this query parsing optimization. I will call it a very general name, like query management. Management. And it has to make maybe several calls to the LLM. It may actually do several API calls to the LLMs, and he will be responsible, for example, to receive. Wait a minute. He will receive the. He will receive the re-ranked. We receive the ranked embeddings. So you have the top embedding, for example, and he will be also okay, maybe it's not with this retrieve. I'm considering that the retriever is going to get this defined system. Not sure this is the best. Yeah, maybe I'm going to do it like this. Okay, so I consider that the after the ranking, it is going back to the retriever, and the retriever is sending the file or files. I'll put it like this, actually files, because there may be some files here to the query management. And now the query management can make a call to the LLM with the query on this particular file. So it has the passport document, and he's asking what's the ID on the passport, and it is going to find this and answer that to the user. You also mentioned the case of images, which is very important. So we need another box here, because
yeah, but you don't have to worry about it. Let's just assume for each file.
For the moment, okay, it's already text, right?
Yeah. Let's just assume that. Okay, nice. Okay, so important question. How do you measure if this system is working well? How are you gonna test it?
Good
And
question.
how are you going to deploy to production?
Nice. So yes, in order um, to test it, usually one metric that is used is the recall. So we will need to have a test set of files and queries that we would typically want on these files, and that we know already what is expected to answer. And then we will test, see if the right chunks are going to the augmented generation, right? It's going to be sent as context to the augmented generation. Yeah, so that would be about the correctness of the retrieval system. And in terms of performance, we would have to monitor. We will have to monitor, and maybe if we find it necessary, we will need different instances running. So we will need some sort of load balancing here, so that we always get this real-time few seconds requirement, right? So we will need to use some sort of scalable. We will need to containerize it and maybe deploy on Kubernetes, so that we may actually create these different instances, so that we can achieve our non-functional requirements. There are many details here, so maybe I'm going to the next part. So I will break it into I will break it into two. We already did it here with this dotted line, but I'll call this first part like, let's say, vector building. I don't know if this is a good name.
Yeah, maybe database building or something. Yeah, it's fine.
Database building. It's good. And I'll call the second part the query search, like this. So let's start first about the DB building. Yeah. So we need to have some scheduled jobs. In a regular basis. I don't know. Maybe every 15, or maybe, I don't know, if 15 minutes. You said real time, so I will put something like, I don't know, 15 minutes to find new files, right? Because it has to go to the filing system and see if something new, if there is something new there, and then chunk, embed, and put in the vector store. We have to define also the chunking strategy, because there are many ways to chunk these files. So do we know something about the characteristics of these files? Can be anything. It's like image,
yeah, I mean,
video,
of
big
course,
documents, small documents.
Yeah, all types of documents. But yeah, let's not worry about documents that do not contain text. For example, like
okay, no, okay, the assumption.
Yeah, like videos, for example. Yeah, we can skip videos for sure.
But regarding text documents, do we expect to have, say, huge files where we are going to search something specific in these files, or we usually we want some sort of global understanding of the file, or we are going to look for specific parts
Well, yeah, I understand what you mean. No, let's say the search will have, a number of characters that will limit the size. Yeah, the search size could be maybe up to like 200 characters.
No. We don't need to fix the search size. That's not the point actually. Maybe I will rephrase it. It's like um, um, one thing is you ask if there is a document there if there is, for example, the result of a particular exam
Mm-hmm.
you did at some point,
Mm-hmm.
and then it's going to look for that particular file. It's usually not a very big file, so this will be the easy case, right?
Mm-hmm. Mm-hmm.
But let's say the complicated case would be like you have many research articles,
Mm-hmm.
and some research articles are actually very big, like 30 pages or something.
Mm-hmm. Mm-hmm.
And then you're going to ask if there is an article where they show a particular result with this or that. They ask like a high level question
Mm-hmm. Mm-hmm.
that you basically have to read the full article, right? You cannot just read small
Mm.
chunks.
I see. I
Actually,
see.
in this case, actually, if by taking the abstract would be sufficient. I don't think that would be a problem here. Actually, now that we discussed,
Mm-hmm.
I would start with a fixed size chunking strategy.
Yeah, but you
Maybe,
you
maybe I
you
would.
can even if you split by chunks, you can also uh just maybe rank the chunks, right?
No,
And
we do
then
that. Yes, that's what we do.
yeah, based on this, you can just return the file
Yeah.
and
I
maybe
think that would be
the part.
sufficient.
Yeah.
If not, we could also parameterize this chunk size. So yeah, I'm going to put it like this so that we don't. This is something that we could be adjusted when we were building this system. So okay, that would be my first guess. Fixed size chunking strategy. For the embeddings, I use some. So the embedder could be something like sentence bird or something like this, like
Mm-hmm.
bird or similar. There are others. Hugging Face is full uh,
Mm-hmm.
of such models.
Mm-hmm.
And for the vector store, there are different ones too. So maybe we use Weaviate or Pinecone.
Mm-hmm.
Phase also use this for the vector store.
Mm-hmm.
And what else? The ranking strategy. Let me see if we can think a little bit about the ranking strategy. Usually we use the ranking when just by looking at the similarity is not sufficient. So, for example, taking your example of passport you gave, um, maybe you will find different documents where you have something about passport ID.
Mm-hmm. Mm-hmm.
So maybe you have, for example, I don't know, laws or rules that say something about passports and IDs, and these are going to be retrieved maybe, but they are not very important for this particular query, right?
Mm-hmm.
So we would need to have some strategies for this re-ranking part that I honestly don't know in advance how that could be.
Mm-hmm.
But yes, I believe there is something that we will need, but uh, for the moment, I don't have many details. I can see it in many.
It's okay.
Okay.
It's okay.
So for the LLM, of course, there are different options. Like, so it is, I don't know, GPT 4.0 or something, right? Gemini.
Mm-hmm.
Gemini. Oh my God. Gemini. For the query management, the query management is also something that we need to we need to manage, to think, also to see, make some tests to see what will be necessary here.
Mm-hmm.
Because my idea of having this query manager is, of course, for building the prompts that are going to be used to the LLM,
Mm-hmm.
but building them in the most optimized way. So maybe the user will ask, like, in very bad English or Portuguese or whatever, and with the query management, we could kind of standardize how these questions are made, so that we can have more control over the kind of results that we would have, right?
Mm-hmm.
That was my my idea here, but it's also not very possible to just think in advance. It needs more time, or maybe just making it very simple. For the API, we could serve it maybe with a fast API approach, so we can have fast API. And as I said, we will use Docker for container, and Kubernetes. We will probably need to also have here a load balancer, right? So that we can distribute to different instances on this Kubernetes architecture. And let me see if I missed something. Oh, there is, I don't know if it's important here, but one very modern problem that we have is prompt injection, right? So people may inject prompts into files, so that when our LLM is going to read them, it's going to follow its instructions or something like this. I don't think this will be a problem here, right?
Can you repeat the last part?
Prompt injection. Have you ever heard about it?
Yeah. Okay.
Yeah,
okay.
because people using in scientific articles, for example, they put a small prompt with very small font, and when if someone is going to use an LLM to evaluate this article, it's going to say it's the best.
Okay.
Evaluated very well. So yeah, it's a
yeah. We don't have to worry
security.
about this.
Yeah.
Okay.
But I don't think that will be a problem here, right? But anyway, if we want, if it could, we would put it in the query management, so that would be a ready justification for also have this. We could sophisticate this part here if necessary. Yeah, I guess that's.
This is great. This is great. Yeah. Okay. Should I continue in Portuguese or English?
Yeah, as you wish. You're the interviewer, so.
Okay. Yeah. No. The first part is great. Yeah, I think you covered like a lot of things. Let me pause my timer here. I'm very happy by the way you designed the system, like very quickly. And you propose like different parts. And then you discuss like everything in details. Yeah, that's very nice. It's a complicated problem to cover like in a few minutes. But yeah, I think you were successful in detailing all the aspects. One follow-up question that could come would be, for example, how do we handle multiple languages? Let's say a person has documents in English and Portuguese. Um, how would your system handle that? Um,
Nice question.
that's one
Yeah.
question. And also, how about, do you know how MCPs work?
Yeah, I have an idea.
Yeah,
Give some
model
small
context
tests, but
protocol.
yeah.
Yeah, the other is like, what would you think of using an MCP here? But yeah, we can skip that part. But in general, yeah, that went pretty well. I think you explained all the parts. It was very nice.
Oh, thank you. Very good. Maybe you're going to hire me now?
Yeah, I'll
That
ask
would be
my
my follow-up
recruiter too.
question.
Yeah,
Yeah.
deixa eu voltar aqui para o português. Mas foi legal, cara. Gostei, viu? É que a ideia do MCP, que eu te falei, é você ter um sistema que ele mesmo usa o LLM para definir quais funções ele vai chamar, sabe? É como se você tivesse uma API com várias definições de função, e cada função ela tem um docstring, né? Uma documentação dentro dela mesma, né? E aí você pode ter funções para diversas coisas, certo? Por exemplo, get file size,
Sim, sim.
Get file title, sei lá.
Seria perfeito aqui. Seria perfeito, entendi.
E aí quando o usuário digita a query, o MCP automaticamente ele escolhe quais as funções vão ser melhores para aquele tipo de coisa que o usuário está pedindo, entendeu? Então, acho que daria para usar também.
Eu acho que aqui nessa parte do query management, isso aí teria exatamente o efeito que eu estava buscando, porque seria tipo assim, a gente identificaria alguns padrões de consultas, né? E aí, para algumas delas, já teria, vamos dizer, um tratamento diferenciado, né? Então, por exemplo, se eu estou interessado em tamanho, talvez a minha consulta ela já vai ter um foco diferente, né?
Exatamente.
Se vai ser relacionado a conteúdo, né? Aí já vai ter outro foco. Se for imagem, sei lá.
E
diferente.
uma outra coisa é que eu tô pensando sobre isso, sabe? Pode ser que eu esteja errado, mas, assim, eu acho que a gente precisaria de um tratamento melhor para saber que resposta ele vai dar para cada tipo de pergunta, certo? O sistema que tu criou, eu acho que ele faz essa questão de recuperar o documento certo, na maioria das vezes, certo?
Certo.
Ou todas as vezes. Tá, esse aqui é o documento. Tipo assim, qual o número do meu passaporte? Ele vai saber o teu sistema, com certeza. Esse aqui é o arquivo que tem a informação que ele quer. Mas eu acho que a gente precisaria fazer um pós-processamento ou um pré-processamento, sei lá, para identificar qual tipo de informação que tem em determinados arquivos, entendeu? Então, por exemplo, uma carteira de motorista, ela tem lá o nome da pessoa, às vezes tem o tipo sanguíneo, se é doador, onde a pessoa tirou aquela carteira de motorista, aí tem a data de expiração, entendeu? Eu não sei se o LLM puro trata isso.
É para
Entendeu?
tratar. Ele é para tratar. Agora, de fato, assim, se, vamos dizer, se for, esse exemplo que tu deu da carteira por exemplo, data de expiração, né, data de validade, na verdade, né,
Isso.
muito provavelmente, se ele perguntasse pela data de validade do documento de identidade, ele conseguiria encontrar, porque essa informação ela vai estar guardada no embed, né, que é gerado, e aí, por similaridade, ele deve encontrar isso. Claro que isso depende dos embeddings que foram, como é que eles foram feitos, né, dos chunks também. Se tu fizer um chunk, por isso que aquela questão do tamanho do chunk também é importante. Se tu fez um chunk relativamente pequeno, né, tipo, vai bater bonitinho, porque aquele trecho, ele vai ter praticamente essa vai ser uma das informações-chave, né? Agora, se uma coisa muito grande, aí já vai ser mais, já se dispersa, né? Como se essa informação se dispersa. Mas, assim, não é tão simples mesmo, não. Tem algumas coisas que podem ser complicadas, né? E uma ideia seria, ao invés de você necessariamente, até uma coisa que poderia vir aqui, né? Se eu tiver que dar a resposta, ok, aí tem que, não é tão simples. Agora, eu poderia só devolver alguns arquivos, né? Ou talvez, olha, nesses arquivos aqui você talvez possa encontrar, meio que deixar para o usuário filtrasse o que era o mais adequado, né? Não sei, tipo assim, se quando eu fizer o retrieval, né, vamos dizer que eu pego os cinco melhores chunks, né? E aí o primeiro está com a similaridade bem alta e os outros estão com a similaridade mais ou menos, ou baixa. Aí eu poderia, ok, aqui eu estou confiante, esse cara aqui deve ser onde tem a resposta. Mas se não, se está meio que disperso em vários pedaços, né, em arquivos diferentes, aí eu poderia dizer, olha, eu estou em dúvida, né, mas talvez você possa encontrar essa resposta em um desses arquivos aqui, sei lá.
Não, isso aí tranquilo. Não precisa. Tem que fazer muito teste, né?
Tem que fazer muito teste.
Né? O evaluation, né? Que a gente chama. E ver se
Como é que tu faz o monitoramento, Leandro, assim, na prática, né? Assim, até uma pergunta que fiquei imaginando que se me fizessem essa pergunta, né? Da qualidade de modelos, que ferramentas normalmente você usa?
Cara, para você fazer o evaluation, você consegue, tem uma ferramenta, aliás, tem várias, né? Mas uma que eu conheço é o Langfuse. Ele faz o tracking, né, de tudo que acontece por trás do LLM, e ele guarda essas informações para você poder usar e ver se a resposta está sendo certa ou está errada, entendeu?
Entendi.
Mas também, aí você consegue, por exemplo, guardar praticamente tudo, assim. Qual foi a pergunta que a pessoa fez, quais foram os documentos que foram recuperados, né? Você pode dar um score para cada documento, e isso aí vai para lá também. E aí você consegue, sei lá, comparar aquele resultado com o resultado esperado. Mas eu acho que também precisaria ter algumas métricas em tempo real, assim, tipo, se a pessoa fez uma busca, você mostrou o documento e ela não clicou no documento, ou você mostrou vários documentos e ela foi clicar lá no quinto documento, no quarto, não no primeiro, entendeu? Esse tipo de métrica também ajuda
Assertividade da coisa,
a saber se o negócio está fazendo certo ou não, entendeu? Então, se a pessoa, sei lá, você pode colocar também um gostei da resposta, ou não gostei da resposta, e a pessoa pode avaliar na hora, sim. E aí
Eu
você
acho
vê
que
se...
ficou até faltando aqui essa questão do vector registry, né? Seria, aliás, tanto do vetor, quanto dos vetores, quanto do embedder, né? Porque eu
Uhum.
posso até ajustar esse modelo, né? Posso fazer algum tipo de fine-tuning no modelo que eu uso para
Uhum.
gerar os embeddings, e posso ter diferentes versões, e pode ter uma versão que, sei lá, não está dando certo por alguma razão ou outra, né?
Pode ser também.
Poderia ter que guardar isso aqui também, né? Uma
É,
coisa
e
que dá
aí.
muita dor de cabeça são os prompts, né? Você guardar as versões dos prompts, porque
Uhum.
isso também tem impacto.
Uhum. Dá para fazer algumas coisas, assim, tipo, tu pode fazer um modelo que é só para empresa, focado em empresa, outro modelo mais para arquivo pessoal, sei lá, não sei, teria que ver se valeria a pena, né? Em vez de criar um modelo só, aí você pode pensar em modelos para diferentes línguas também, para funcionar direitinho, né? Mas, enfim, cara, deu para cobrir muita coisa aí, foi legal.